If you're completely new to Unreal Engine or honestly just looking to brush up on a lot of the basics, this is the tutorial for you. Today we're going to be recreating Pong using Unreal Engine as a way to show off the key components of learning Unreal for you to take into your own projects and experiments. If you're hoping to dive straight into the tutorial, skip to the next chapter, because first I'm going to walk through why we're going to be making Pong, and I'm going to give a quick overview on what you can expect to learn in this video. So in my opinion, Pong is one of those games that is perfect to learn a new game engine. Why? Well, let's look at the scene. This is ultimately what we're going to be making, or at least it's going to be close to what we're going to be making. We have our paddles, we have a ball, we have this scoring zone over here, and then we have walls that mark the play area. It's a rather simple game, but each of these components is going to teach us something fundamental about how Unreal Engine works. Through our player paddle, we're going to get a sense of how we can handle player input so that our player is able to actually interact with the game world. Through our ball, we're going to be able to understand collisions, and we're going to be able to learn how to trigger events to happen after we do collide with something. Our enemy paddle is going to teach us about the very basics of enemy AI. How can something like a computer just respond to the world that is happening around them? Our score zones are going to show us the importance of overlapping, and it's going to allow me to go into more detail about how Unreal handles collisions. And then of course, I'll cover a little bit of user interface by putting the player's score on the screen and giving us a little bit of a game over screen. So without further ado, let's start by creating our project. Open up your Epic Games launcher and let's navigate to the Unreal Engine section of it. If you hover over the library here, you're going to see all the engines that you have installed. For the purposes of this tutorial, I'm going to be using 5.4.4 because that's the most recent engine version at the time I'm making this, but nothing I'm doing is so complicated that it shouldn't work in the future, or if you're using a past version as well. Assuming that you have your version installed, let's click on launch, and then let's wait for this to load. Once launched, it'll bring up all of the recent projects that you've worked on, but we're going to navigate over to this games subsection here, and we're going to click on the third person template. Are we going to use the actual third person template? No, we are going to build everything. I want to use this as a way to introduce a few concepts to you. On the right hand side, we get to choose between a blueprint project and a C++ project. Don't get bogged down by this. We are going to leave this as a blueprint project, but we are going to use C++. This is not a one or the other solution. We have to use both in tandem because there are strengths to C++ and there are strengths to blueprint. I consider myself an intermediate Unreal Engine user at best, and I find that the most productive I am comes when I'm using C++ to make the things that I want to implement, and then I use blueprint to connect them. And if that makes no sense to you right now, don't worry, it will by the time we are done this video. Your target platform can remain as desktop, and your quality preset, I'm going to switch to scalable just so that things load a little bit easier on my machine. I recommend keeping starter content on. It just gives us more things to play with as we go around. In the bottom right hand corner, we can name our project, and I'm just going to name mine Pong because I'm not very creative, but from there you can hit create, and then we're going to wait for the engine to load. Once your computer loads, you will have a scene that should look near identical to this, assuming that Epic hasn't overhauled the third person template in future versions of the engine. But what are we looking at here? This giant window in the middle of your screen is what I'm going to refer to as the viewport. This is a representation of what your level looks like. So if I was to hit the play button up here, we would spawn into this world that we have direct ability to interfere with. And we'll get into how to do that in just a bit. On the right hand side is the outliner. This is a summary of all of the items that are in your level. For instance, if I just click on a random cube, you can see that it exists in the outliner and it gets highlighted for us. And vice versa, if I click on a random cube, it will outline it in the game. So these two have a relationship between each other. Speaking of relationships, any item that you select that is in a level will have associated details, and that can always be found under the details on the right hand side. These details are item specific, so the details available on this wall are going to be entirely independent of the variables on this cube. So for instance, if I go over to the scale variable here and I just chop in the number 10 instead of 1, you can see that this cube gets really long, but nothing else in our scene is actually touched. Remember, if it's in the viewport, it can be its own instance and therefore is independently altered. You'll notice that attached to the details pane here, I have world settings. If you don't see world settings, which is entirely possible, you're going to go over to the window tab in the top left, and then you're going to click on world settings. And this will, somewhere on your screen, make world settings show up, and then you can just dock it wherever you want. I've grown into the habit of having my world settings over here, but that does not mean you have to. World settings, as you could probably guess, holds settings that have to do with the entire world or the entire level that we are dealing with. Speaking of things you might not have, on the bottom I have the output log. This is just something that shows logs or code or whatever we would like to show up as we go and run through our game. If you can't see this, once again, go to Window and then go to Output Log, and then you'll be able to dock that to wherever you would like. Now, one thing that is missing here is called the content drawer. For some reason, in the new versions of Unreal Engine, they stopped putting that on screen by default. You can see that in the bottom left, it is collapsed, and if I click on it, it does show up. But for some reason, if you go to where the icon for Unreal Engine is on your desktop, they also have opened it as its own standalone file for some reason. So feel free to take that and then drag it and put it on so so that it stays put. So now that you have the basic setup of the viewport that I am accustomed to using, let's talk about using the viewport specifically. If you click within your viewport, you will notice a few things. First, if you hold down the left mouse button, it gets a little bit weird and it's kind of like you're playing a first-person game. I don't recommend that. What I recommend instead is holding down the right mouse button. This allows you to basically act like you're in a first-person video game. You can look up to look up. You can look down to look down. Right, left, it's all there. And if you want to actually navigate through the level, you can hold W to move forward, S to go back, A to move to the left, and D to go to the right, just like you were playing a first or third person game on your computer. So let's go and look at this cube here. If we click on this cube, you can see it has a nice little orange highlight. If at any point you want to focus on something that you have selected, you can press the F key, and that's going to bring you up close and personal to whichever you have selected. It can make it a little bit faster than trying to manually walk over. Personally, I find this a little too intimate, so I'm just going to scroll back or zoom out by scrolling backwards on my mouse wheel. From there, we're going to talk about our base adjusters. In the top right-hand corner, you can see we have 4 tools that are the most common to use. We have Select, Translate, Rotate, and Scale. They are bound to Q, W, E, and R, respectively. When you have an object selected, you will see a little gizmo in the heart of it that changes depending on which tool you have active. Starting with Q, or Select, this allows you to just select things in the world. I use this tool when I want to make sure that I am just clicking on something to view details, because when you use the Select tool, it cannot accidentally move things out of place. Moving to our Move tool, or the W key, you can see now we have a gizmo, and this allows us to translate or move an object in our scene. We can do that in 3 directions: the Z-axis, which is blue, the Y-axis, which is green, and the X-axis, which is red. Feel free to mess around with that. And something that I'll draw your attention to in the top right-hand corner is known as the snapping distance. Both the Move tool, the Rotating tool, and the Scale tool have different snapping presets that you can change to fit your workflow better. Unreal Engine uses the metric system, so we're talking centimeters and meters a lot of the time. Honestly, there is no consistent reason to tell if something is going to be a centimeter or a meter, but the smaller the number, the more likely it is that it is a meter. Regardless, we can change our snap size here to be 100. That is 100 centimeters or 1 meter. So now you can see as I translate this object along, it doesn't move until it is all of a sudden going 100 centimeters over, or that next block over. Snapping is a great way to make sure you're consistently moving items along fixed amounts. Next, we have the Rotate tool, or shortcut E. This allows us to rotate along the 3 axes. This would allow us to do things like set up the field of view for a camera, or just change the way that our character is holding a sword. But overall, like the Move tool, it is not the most complicated. Next, we have the Scale tool, or shortcut R. This is how we make objects bigger or smaller. Again, we can do so in any of the 3 axes by just selecting them and then dragging. So if we wanted to make this blue square a little bit longer, we could just drag it in whichever axis we wanted to make it longer. And then since it starts clipping through the floor, we can switch back to our Move tool with W and then raise it back up so that it's above the ground. So that's the basics of item manipulation in a scene. Now that we have that, I'm going to show you this play button here. This lets you play the level that we're working on. So you can see when we hit play, since we're using the 3rd-person template, we get a 3rd-person character that we can then go and explore the world. And you can see here, well, there's our really big cube that we were just working on. This allows you to test changes as you make them. It's pretty handy. Now, that character that you just saw corresponds to a blueprint that exists in our file structure. If we go to our content browser on the bottom and go to Content, 3rd-person, Blueprints, and then open up this BP_3rd-person character, this will show you all of the quick and dirty of what that character can do. Everything in Unreal Engine at its core is made up of components, and a blueprint is a way to use multiple components at the same time. We're going to talk more about this as we go, especially as we start making our own creatures that have their own components. This will become a lot more clear. But for instance, for this character that you saw, they have a capsule component that talks about what they can interact with or collide with. They have an arrow, which points them in the right direction, a mesh, which represents their bodysuit, and then a camera boon, which keeps the camera away from the player, and then the actual camera, which gives us that perspective that we were playing with. This one blueprint encompasses all of these components, including this character movement component that lets our character move around and jump. Now, at this point, you're very likely feeling a bit overwhelmed, but don't worry. This is more complex than anything we are going to be building today, to be honest. And by the end of this, you should at least be able to have a basic understanding of what is going on here, but that is for future you to come back and review. So now that we do understand the absolute basics of the editor, we're going to be able to actually start making Pong now. So here's everything we're going to be making today. So let's start by creating the actual level that we're going to be playing in, so that as we continue to add different things, it's going to become obvious what they're used for and where they should sit. To create a new level, we're going to go up to the File menu in the top left, and we're going to click on New Level. For our purposes today, we are going to choose the basic level because all that comes with is a floor and not any complicated lighting. From there, hit create, and it might ask you to save. If you haven't reverted any of the changes for that big cube, feel free to hit save. So we now have a blank level that is our canvas to make whatever we want. The big thing about Pong is the perspective. We're looking down at Pong from above. So we're gonna need a camera angle that is going to be able to do that for us. So let's start by adding a camera to our scene. Near the top left-hand corner, there is this little square with a plus sign. This allows us to add objects directly into the scene. So if we click down on that and then type the word camera into the search bar, it's gonna bring up everything that has to do with cameras. For us, we're gonna wanna add a camera actor, and then when we click on that, it's going to add it to our scene, and now we have this camera floating in space. You don't have to follow along with this next part, but I'm just gonna show you the differences between orthographic and perspective cameras. If I go and add this cube to our scene, and I just go and throw it down, let's take our camera and move it closer to the ground. You can see here in this camera preview what the scene is going to look like. In the camera's details, we can see that the projection mode for this camera is currently perspective, which means everything is done in the 3D perspective of the camera. As such, we can clearly see the depth here. We can see that the square is not touching the ground. But if I go ahead and switch this to orthographic view, we can see that it no longer really cares about the z-axis. And you can see that that's really true when I start dragging this upwards. It's only moving where the camera is because of this angle that we're sitting the camera at. If I go and use my rotate tool with the E key and then make it look straight down, and then I move it so that the cube is in focus, as I move this up, you can see it no longer cares because everything is made to be flat when we are using an orthographic camera. Since I like this flat style, we are going to be using an orthographic camera for Pong. The most important thing for an orthographic camera is this detail here called the ortho width. This represents how much space is going to be shown by your camera. We can see with a 1500 ortho width, we can see a little bit. But if I change this to say 4500, we all of a sudden are seeing a lot more of this total play space that we have to work with. So I hope the difference between an orthographic and a perspective camera makes sense. I'm gonna clear away all of this, and now we're gonna do it together since I told you not to worry about following along for that last part. So let's go into the top left-hand corner and quickly add a camera actor. Once it's spawned in, we'll make sure that it's selected, and then we can go to the details pane on the right-hand side and change our projection mode to orthographic. You can see that the preview starts to freak out, and that's because our camera is looking straight ahead on the x-axis, which has nothing to interfere with it. If I hit the E key to go to the rotate tool and then rotate this 90 degrees towards the ground, you will see that it then can see our little checkerboard. From there, I'm going to change my ortho width to be that 4500 because that just feels right. And then using my move key, or the W shortcut, I'm then going to move my camera towards the middle of the scene. So now when I hit play, we'll have this nice tall camera angle. Let's hit play. That's weird. We're still using that third-person character camera. Well, the reason for that is because, as I showed before, this third-person character, which is what we're controlling, has a camera attached to it. And by default, this camera is going to be the one that we want to use, which makes pretty good sense. There is code that we could do to make our new camera automatically be the camera that we choose. But for the purposes of this, since there's only going to be one camera, we're just going to force the issue. If you ever want to force a camera perspective, you can go into the camera details, and we can see that our camera actor is still selected here. And then we can scroll down to this auto player activation section, and we can auto activate for player number player 0. Computer science, we like to start counting from 0 for some reason, so just remember that the first player character in this single player game is going to be represented by player 0. Don't worry, multiplayer stuff is really complicated, and we will not be touching it today. So now that we are auto activating this camera, which I seem to have lost, and remember, if I ever want to find the thing that I have lost, I can make sure it's selected in my outliner, and then I can hit the F key. If I want to make sure that this camera is automatically going for my player, I have auto activated it for my player, and then when I hit play, we can see that we have our nice tall sky view of our map. Fantastic. Now to stop myself from losing this camera every single time, I'm going to move this all the way down to earth here so that I can actually see it when we're making further changes. Remember, as we go up and down with this camera, it doesn't actually change what we're seeing because we're using that orthographic camera that doesn't care about the z-axis as much. Everything is considered to be flat. So now what we're going to do is we're going to set up our walls to kind of cement our play area. There is no easy way that I found to do this, so I'm going to teach you my little cheat. In that top left-hand corner, we're going to quickly add a cube. Let's start by going to the cube's details on the right-hand side here and making it go to position 0, 0, 0. And we can see that throws it pretty much directly into the middle of the level down there. Now from there, if we go to our camera, we can see that it's not quite in view. So I'm actually going to center my camera at 0 on the X and 0 on the Y, just so that we can line things up a little more consistently from now on, and then it can stay at that 1600 on the Z. So we can now see this cube just in the middle of this scene. That's fair, we haven't moved it yet. But whenever I go to click on my cube to move it, I lose my camera preview. Well, if I click on my camera, the good news is if I hit this little pin preview button here, it will then stick that preview to my viewport so that as I click on other objects, I can still see what the camera would see. This is going to allow us to cheat a little bit because now we can just drag this block in a direction and then we can note where the walls are going to be. So I can see now I've dragged this over here. And now if I hit R to resize, I can drag this and then resize it so that it happily takes up that entire right wall in that viewport. If you're scared, you can even make it take up more than it because we're restricting, based off of our camera, what the player can see. So if this wall happens to be this big, but it only sees a third of that, it doesn't really matter because mechanically it's still just a wall and our camera still sees it as just a wall. Now from there, we're going to go and we're going to make a duplicate of this wall and we're going to drag it all the way to the other side in order to add another wall. If you ever want to duplicate something that's in your scene, you're going to hold down the Alt key and then as you're dragging, you'll see it automatically creates a new one. So remember, to duplicate, hold Alt before you move and then it will duplicate that item. And then you'll see we're able to drag that all the way to the other bound of our camera preview here. And I'm going to duplicate one more time. Again, I'm holding Alt, I pop in a new one to existence. I'm gonna move that about to the middle of the scene here. And then I'm going to hit E to open up my rotate tool. And I'm going to rotate this 90 degrees so that we can form another wall. And then with my move key, again, W, I'm going to move that to form the top of my wall. And then holding Alt one more time, I'm gonna make a fourth wall that I'm going to drag to the bottom. Now, something that I'm not going to do that I do encourage you to do to get more comfortable with the viewport is to make this perfect. You can see that it is not necessarily an entirely perfect fit and that you can see a little bit of tearing in the corners with these walls. For the purposes of this tutorial, I am not going to make things a pixel perfect fit, but I do encourage you to mess with both the snap size and scale snap size in order to make it so that all four walls do snap tightly together. But for the sake of time management, I am not going to go and mess around with that right now. So now when I hit play, you can see that we have our wall that's not necessarily a perfect fit, but it is good enough. So looking at our scene now, we have this nice long white border. But what if we wanted to change the color? So if we selected a wall, and then we went to the static mesh component, we could see here the material element for our static mesh, which represents the skin suit that is in the actual game. We'd be able to change the material here to say a green or a black or whatever color we would really want. But you can see that it's only changing that one wall. Right now we have 4 instances of a wall representing each of our walls. If we wanted to update something to happen to all of our walls, we would have to make 4 different edits. This is where blueprints or having that master copy comes in handy. But a lot of the time you might be quickly making a little mock-up of something inside of the viewport and then want to save your work. You can select whichever object you want. Then you can click on this little blueprint button over here. This converts whatever we're clicking on into a reusable blueprint class. So if we click on that, we'll say this is a new subclass of the type static mesh actor, and I'm going to call this my BP_wall. BP, of course, standing for blueprint. And where am I going to put this? I think I'm going to put this in the top of my content folder. So if you ever want to change where something is going, you can click the little folder icon next to the path variable and then select where you want it to go. If I hit select now, it's going to open up the blueprint version of our wall. And if we go to our content drawer, we can see that it has created a new blueprint version of our wall. For the sake of driving this point home, I'm going to drag out a few different walls for us to reference here. We can see that all of these walls are green, just like its original changed wall. but all of these other InstanceOfs that we had pulled earlier still remain white. If I wanted to change all of the white walls to be green, I would have to go and do that change 3 times. But let's say down the road, we really want all of our walls to be black. Well, if I go into my blueprint for the wall, change to our static mesh component, and look at our element, we can change that. And let's say we do this black unlit material here. And then I hit this compile and then save button in the top left-hand corners. When I go back to my scene, every instance of the BP underscore wall that is in the world has gone and changed color. So real quick, what we're gonna do is we're gonna replace each of these white walls with the blueprint version of these black walls. Mechanically, it's the exact same thing. But now, if we ever wanted to update all of these at once, let's say to this bone weight material that's a little bit of a rainbow, we'd be able to update the entire perimeter wall all at once. Now, this is a little obnoxious, so I'm gonna go and change this back to just the straight black unlit material, but you get the point. So we now have a basic world that has a camera and 4 walls that define our play space for our top-down game here. But we actually haven't saved anything yet. You can see here in the top left corner that this level is still called Untitled. If I hit Control and S together to save this level, it will bring up the Save As menu. And just for organization, I'm going to right click to open up a new folder that I'm going to call Levels. And I'll make sure that our level that I'm going to call Pong level is saved into this levels folder. And then we're nice and organized with our Pong level saved, and we would then no longer be at risk of losing all of our data. Now we're ready to get started to create our paddle. The goal for the paddle is to be used by both our player and our computer in order to move vertically and smack the ball when they need to. We are going to make our paddle using C++, but I think it's important that I explain the main differences that I see in blueprints versus C++. So blueprints are honestly great and can do a whole bunch of things if you don't have formal coding experience or if you just like the visual style of coding. But I find that blueprints are really rigid. Going out and creating really complex behavior is difficult, or at least awkward in Blueprint. Whereas in C++, you can create things with a lot more flexibility and can scale things a lot better. So despite the fact that we're making a very simple project here, I'm going to show you the basics of C++ so that you can use that as a fundamental piece of knowledge for when you want to go and start making your own projects. But that doesn't mean we shouldn't use blueprints at all. Blueprints and C++ need to work in harmony. It is not a one or the other. You're going to use both. The workflow that I was taught is to use C++ to make the actual mechanics or things that you want to see, or all of the interactions that you might want from a design perspective. And then you use blueprints to actually implement those design decisions. So for instance, for our paddle, we know that a paddle is going to need something that collides with the world and something that has a skin suit for us to see in the game. We also know that it's going to need to move up and down. So we can set up a contract and add components that are going to be able to accomplish each of those goals. And then once we have that skeleton set up in C++, we're going to create a blueprint version of it. And then we can fill in all the nitty-gritty details, like what exactly we would like to happen when we press the move upwards button. My favorite benefit of this approach is this means that our C++ class does not need to know everything about what's going on, and we don't have to use very specific language and syntax in order to get the same behavior. But I'll explain more about that as we go. So to create a new C++ class, we're going to go to the top left-hand corner and click on Tools, and then hit on this New C++ class. That's going to open up a pop-up that's going to let us choose a parent class. The parent-child relationship is something that gets explained in computer science to the nth degree. But basically, you just have to decide what is the basic amount of functionality that I want here. The common classes illustrate all of the things that are very frequently used inside of Epic projects, but sometimes you might be looking for something more obscure, and then you need to look inside of all classes. For our purposes here, we want a paddle. The most complicated thing our paddle is going to do is receive input from our player. So if we look at these 4 options here, we definitely don't want none because we don't really want to build everything from scratch if there's a template available for us. If we're looking at character, a character is a type of pawn that includes the ability to walk around. A pawn is an actor that can be possessed and received input, and an actor is something that can be placed or spawned in the world. So to drive this home, an actor is a base class and is the parent of the pawn class. The difference between actor and pawn is that a pawn is an actor that is already set up to receive input and be possessed by a player. The pawn is a parent of the character class. What separates character from pawn is that they have a whole bunch of other components that are set up, such as a skeletal mesh and character movements component that allows more complex behavior such as flying, swimming, and walking. Our paddle is not a human. They do not need to swim, they do not need to walk. Therefore, we're gonna go with the pawn here because we just want them to be able to receive input from a controller, but we don't need them to actually do anything complicated. Choosing the parent class is something that you will get more comfortable doing as you make more and more things. But that's the basic understanding of actor versus pawn versus character. So with pawn selected, click on next, and then we're going to choose the class type, the name, and the path. The path is going to be fine where it is. We are not making enough C++ classes for us to worry more about where we're placing things. The class type here is public versus private. What you're going to see when we create this is you are going to have a header file or a public file and a C++ file or a private file. You always get both, but for some projects, you want to have your header files completely separate from your private C++ file. Again, that is all about how you want to organize things. This is a very simple project, so I'm just going to leave everything in one folder. As for the name, this is going to be called paddle because we're making a paddle, and then we're going to hit create class, and then this is going to open up Visual Studio or whatever code editor that you have set up as default. While everything is loading, you might have a few pop-ups that talk about how source files now exist, among other things. Just simply accept and then move on until Visual Studio launches. And once Visual Studio comes around town, we are going to have two files. We have that C++ file and a header file. A header file is that public file that sets a contract on what is allowed and being done in the C++ file. So the header file is public and tells everyone what is going to happen. And a C++ file is where all the deep and dirty code is done and actually implements the things that you say you're going to do in the header file. For instance, inside of the header file, we are going to declare that we need to have a skin suit, something that collides with stuff, and eventually a movement component. But all we're saying is that they exist. It's in the C++ file where we're actually going to create those objects and then use them in the game. Now, there are some issues with using C++ in Unreal in general. It is worth these pain points to use it because flexibility is key. Please note, because I will forget, the biggest issue that you will run across is that if you are ever changing a header file or a public file, things are going to get weird if you compile it and then just open the game back up. As such, whenever you see me working in Visual Studio and I am adjusting a header file, just know that I have my Unreal Engine closed. To close out of the game, you are just going to hit the X in the top right-hand corner, and then anything that you are building inside of Visual Studio, when you compile it, will automatically be there the next time that you open up the project. So this is us erring on the side of caution. Just make sure you have your Unreal Engine project closed when you're doing coding changes. It'll save you a lot of confusion and heartache, I promise. So now that I've explained the basic difference between a header file and a C++ file, let's actually talk about what we're seeing here. This is not a coding tutorial where I'm going to teach you the absolute basics of programming, but I am going to go over some of the major details just so that we're all on the same page. The one thing I always like to explain is the difference between a public, a protected, and this private section that I've just added. Anything that is public can and will be used by anyone, so it is available for anyone to see. You could say it's available to the public. Similarly, something that is marked as private can't be seen by anyone but the person that owns it. So if I put something inside of the private section, then only the paddle is going to be able to use it. And in the middle, we have protected. You can think of protected like a protective parent. Protected stuff is something that the parent, or in this case, a pawn, or your grandparent, an actor, has already created that you want to also use. Sometimes you want to just throw out what the previous generations have done and done your own thing. That's usually marked with this override. But if it's in the protected section, then anything that inherits from us is also going to be able to use it. There are plenty of great programming tutorials that can explain these concepts further, but this video is already going to run long, so we're just going to start coding now. Something fundamental to C++ for Unreal Engine is something called a UProperty. When something is marked as a UProperty, then it is going to in some way be exposed to Unreal Engine. And we can set up specifiers inside these parentheses in order to share where it's going to be. I'm going to open up Unreal Engine and show you a little bit of this. You don't have to follow along with this part, but I'm going to open up our wall blueprint from earlier. If I select my static mesh component here, I can look on the right side and all of these details are in code somewhere. These are all UProperties. They're all UProperties that have been exposed to the blueprint in some way. So there's a UProperty that states that we can choose a static mesh. And then that static mesh has a UProperty that says we can choose what material it can be. It can also be as simple as where the object exists or how big it is, like this scale up here. But you can see here there are restrictions on what we can place in each of these. And that is the power of UProperties. I can't say that our static mesh is equal to 5. We aren't allowing that. That makes no sense. And further to that, we are also able to add components in C++. There's so many components that you can use, and you can get a good list of them by looking into the top left of any blueprint window and hitting this add button. There's sounds, there's skeletons, there's stuff as complicated as seeing things, and there's stuff as simple as a sphere. In order to add these in C++, there are extra steps we're going to need to take, and I'll show you those as we go here. But if we think about the paddle we need to make, we know that we need a skin suit and something that collides with the world. For something that collides with the world, we can see this collision section here, and we have a box box, a capsule, and a sphere. Well, our paddle is going to be mostly box-like, so a box collision is probably the best thing for us. And if I click to add that to my wall temporarily here, I can right click and then I can open boxComponent.h. Then in Visual Studio, that finds that header file or that contract file and lets us see everything that the box component can do. And we can see here at the top that it says it's a box generally used for simple collisions where bounds are rendered as lines in the editor. That sounds perfect for something that will collide with stuff in the world. So if you're ever curious and want to poke around, I'll leave this link in the description, but there is a full reference of everything that Unreal Engine has pre-built as a reference point. It talks about hierarchies, classes as a whole, all the constants that you can use. Everything that you could want to find will be here somewhere, but I will say it's also really hard to navigate. But in general, if we're looking at classes, we would also be able to find that box component by searching for it. And you can see here it's the U box component, and if I click on that, it gives us a whole bunch of useful information. The most important thing that you'll find here is the include, and I'll talk more about those in a second, but basically you need to have an include statement in order to actually use the actual components inside of C++ files. But more important to that, everything that can be done by a box component gets outlined here. All the functions that are a part of it get outlined and show what they do. Anything that gets overridden from their parents are put here. So this is a hell of a resource for you to be able to access that's going to help you when you're trying to figure out, well, what can this do? Does this fit my use case? So let's go back to code. The reason that we're going to set this as a U property is because we do want to edit it and see it within our blueprint. But we don't necessarily want our player to be able to make things happen on the fly. So something that we're going to get in the habit of doing is setting what's called as a specifier. This specifier, called edit defaults only, does exactly what you think it would do. This means that inside of the blueprint editor, we're going to be able to edit all of the default values of all of the properties of whatever this variable is going to be. We are not going to be able to change the component once the game is actually started. To declare a U property is just like how you declare any other variable. It needs a type and then it needs a name. Whenever you're dealing with components, it's good practice to make sure that it's a pointer. A pointer means you're not actually making the physical thing. It means the physical thing is going to be somewhere else in the system and you have a pointer that lets you talk to it. At least that's the very bare bones way that I'm going to explain pointers. And if you want to deal with pointers more, I would recommend looking up a formal programming tutorial. Now, what is our type? Our type is a U box component. And what's the name gonna be? I'm gonna call this our collider. This should be good enough, but like I said, we need to have information about this UBox component. To give a brief overview of why we're getting this squiggly mark, basically a header file or any file needs to be able to access the other files. The files that they have access to are noted at the top with these include statements. If we were to include the box component here, then eventually, if this project was grander in scope, things would slow down quite a bit whenever we're compiling. As such, it is considered proper practice to always include things inside of the C++ file where they're actually being used. But that doesn't solve the issue that we're experiencing inside of this header file. Our header file still needs to feel good about the fact that we're going to be using the UBox component. We're going to make a promise to ourselves right now with the word class. This is called forward declaring. When we forward declare something, we are promising that we are going to put the include statement inside of the C++ file. And if we don't, well, the machine will yell at us, but at least the header file isn't going to yell at us. And you can see once the system refreshes itself and starts thinking that we no longer have that red squiggly error line underneath UBox component. And that's because we made a promise to include that inside of the C++ file. I have yet to figure out a way to know which files are included by default and which ones we have to forward declare, but you will know for sure if you see a red squiggly mark under them, okay? This represents our collider, and now we also want a skin suit. So I'm going to copy this because the code is pretty much the same, and I'll paste it here. And instead of it being a UBox component, this is going to be a U static mesh component. I will save you the pleasure of having to look up that on your own. So now we have made a promise that we are going to have both a box component for collision and, let's change the name here to be mesh. We are also going to have a mesh that is going to represent our physical space in the game. We have not actually created them yet. So how do we create them? Well, we're going to go inside of our C++ file. But first I need to explain the concept of a constructor. Inside of this first public section here, we have this method that is called the same name as our class. This means that this is known as a constructor. A constructor is where we set up what happens when this object gets constructed. So this is a great place for us to set up all of the default values that we want to take place. All of this can be overridden in blueprints, but we need to have it set up so that when this gets created, we actually have things show up. So let's go into our C++ file. The method is already created here, and we're going to add to this block of code. Let's start with our collider. We called that collider, and this is going to be equal to a method that is called create default subobject. Create default subobject is what is going to actually allow things to show up up in the blueprint editor. Create default sub-object is what puts the box inside of the blueprint. In order to have this happen properly, we need to specify the type, and then we need to give it a name that'll show up in the editor. As for the type, well, we know that already. This is going to be the UBox component. And then we're going to give it a name. And the way we give it a name is we type text in all caps, and then inside of parentheses and quotation marks, we're going to give it a name. And I'm going to call this my box collider. And then we always have to make sure that for every opening parentheses that we create, there is also a closing one. So we'll have to add that second one there. And then we use a semicolon to denote the end of line. This all looks good so far. So now we want our collider to be the big boss. And the way we're going to do that is we're going to set up the root component to be our collider. To do that, we can find the variable called root component, and we can set it to be equal to collider. Now, this is going to throw a red squiggly mark because it's having a hard time registering that this is a thing. The reason for that is because we haven't included that file. We broke our own promise. Now, if we go back to the documentation that we highlighted earlier, it does give us the include that we need to place here. So I'm going to copy that, and then I'm going to paste it as a new line. You can see once I have this include statement at the top, that squiggly mark goes away, and it can now recognize that collider is in fact a thing. We're now going to do the same thing for our mesh. So copying and pasting that code, we're going to change this to be our mesh, which is going to be equal to a default sub-object of type uStaticMesh component, and it's going to be named mesh. Now, further to that, we want our mesh to follow around our root component. And the way we're going to do that is we're going to call our mesh variable, and we're going to set up attachment to our root component. So let's show you what we have just done now. Remember, with your Unreal Editor closed, we are now going to save with Control-Shift-S to save everything, and then we're going to build. We can do that by at the top menu hitting build and then build solution, or you can hit Control-Shift-B, which is the shortcut I will be using from now on. At the bottom, it's going to build, and you're looking for this message at the bottom where it says that one has succeeded and nothing has failed. That means that everything that you have coded has been done from a syntax standpoint correctly. From there, we're good to open up our project again. So let's open up our Pong. So in order to now build a blueprint based off of that C++ class, in our content browser, you can go to C++ classes, click on Pong, and then right click on our paddle, and then create a blueprint class based on paddle. I'm going to put this on content because we're not caring about being organized for this small scale tutorial here. And I'm going to call this BP_player paddle. And I'm going to hit create paddle class. Once that's opened, what do we see? We have our collider, which is called the box collider, and we have our mesh called mesh. And we can see here that the collider is the parent object and mesh is a child of collider, and we'll follow it around. Then from here, we would be able to actually set up the details of these two components. So for instance, for our mesh, I can go over to the static mesh category here, and let's search for the word box because we don't want anything too crazy. And I'm going to do this control rig box solid. That sounds good enough for me. And then if we go to the collider, we can adjust these bounds of the box extent, and I think it's about 50 on each side, to then perfectly encompass our box. We might change that later, but for now, we have now adjusted our collider and our mesh. And that is the relationship that we can create between C++ and Blueprint. We're going to create methods, functions, and variables that are all going to be available to blueprints as we continue through this tutorial. So now that we have this fundamental paddle that has both a collider and a skin suit, also need it to move around. The big thing that I want to stress here is that Unreal Engine has so much stuff that's already been built for us. So before you try to build anything on your own, try and find something that might already exist that already suits your purposes. We need to move around. Surely Epic has something that will allow us to move around. So if I hit this top right-hand corner here to add, let's just look and see what options we have available to us. If I type the word move, we can see that there are 4 main types of movement that are coming up just off of the keyword move. We have floating pawn movement, which is a movement component that provides simple movement for any pawn class. That sounds pretty great. We have interp2 movement, which is where we allow our root component to move between a series of points. That's not exactly what we're looking for. We have projectile movement, which is pretty self-explanatory. I'd use that for bullets or something. And then we have a rotating movement, where we have continuous rotation of a component at a rotation rate. All of these would be good in specific scenarios, but for us, we're going to be using floating pawn movement component. If we add that here, I will note that this does not add this in the C++ file. I'm doing this temporarily so that we can figure out what we need to add inside of our C++ file. If we just wanted our player paddle to have this, then this would be fine because then this is isolated to our blueprint, which is for our player paddle. But our enemy paddle is also going to need to move. So we're going to add this at the base, which is our C++ file. But as such, we're now going to right click, and then we can see that this is is called the floating pawn movement.h. If we go back to our API reference and click on classes, let's see if we can find this. Floating pawn movement. There we go. Here is the U floating pawn movement. If I click on this, we now have everything we'd ever want to know about how to use U floating pawn movement. This is the process that I use between following tutorials just to find out what was out there and a little bit of digging on my own in order to start experimenting with stuff. And this is the process that I recommend you follow if you're ever experimenting on your own. Tutorials are a great way to see what exists and how you can use them at a basic level, but then documentation is what lets you get into the nitty-gritty of it. And for the purposes of time, I'm no longer going to be using the API reference in this tutorial because I've shown you a couple of times now how you can leverage it. So now we're going to go into our C++ file and we're going to update this floating pawn movement so that it shows up by default for our paddle. As such, I'm going to delete this off of this blueprint because it is naughty and does not belong in our C++ yet. I'm going to compile and save, and since I'm going to be making changes inside of code, I'm going to close the entire editor. So just like before, there are two parts to this. Our header file portion where we're declaring our intent, and then our paddle C++ portion where we're actually doing the thing. Starting in our paddle.h, I'm going to copy this because I like to do the similar thing for all of my components. And this is still going to only allow us to edit our defaults, and this is going to be called U floating pawn movement, and this is going to be called our movement component, or comp for short. Now if we go into our C++ file, our move comp is going to be equal to a new default sub-object that is called U floating pawn movement, and we are going to name this our movement, and then of course semicolon. And you can see here this is giving us a squiggly line, probably because I misremembered our variable name, but maybe IntelliSense will tell me. Yeah, I called it the movement component, so now everything actually exists and that's fine. Now notably, our movement component is not going to take up any space in the world. As such, we don't need to parent. If we were to attach this to the root component, I'm sure everything would be fine, but my habit is to leave everything that doesn't actually move inside of the world separate so that it's a little more organized. So now with that done, we're going to hit Control-Shift-S to save, Control-Shift-B to build, and we're going to see if we did this right. Of course we didn't. We haven't included the U floating movement header file into this file yet. So from our documentation, we're going to grab, and then we're going to place this include game framework / floating pawn movement.h. Now if I hit Control-Shift-S, Control-Shift-B, the build succeeds because it has access to everything that we need before we build. And as such, we can now open up our Pong again. And you'll first notice that we're back on that default level, and I'll come back to that in a second. But first, I do want you to open up your player paddle. If we open the full blueprint editor, we can now see that our movement component is here. So the changes we made in C++ did in fact work, and now we have access to this movement component on every paddle. Now, it's not ideal that we keep coming back to this map. I will say it is easy enough to just go into your levels folder and then open up your Pong level. That can get tedious when we're making a lot of coding changes. So how do we change the default map that is being set up? If you go to the top left-hand corner, you can hit on Edit, Project Settings, and then in that pop-up that appears, you can go to the Maps and Modes on the left-hand column, and then here you can see the editor startup map and the game default map. I'm going to change both of these to be our Pong level that we have created. There is no formal save button here, so you can hit the little X, and then to show you that this works, I'm going to close out of my editor, and I'm going to relaunch Pong. And now you can see the first level that appears when we relaunch our game is now the Pong level, which is going to save us many minutes over the course of actually editing things. Now that our paddle is basically set up, we are now going to go and set up input. To start our discussion with input, I'm going to create a new folder that I'm going to call input. Now inside of this input folder, we are going to talk about two different things. If I right click inside of this content browser and go to the input section, you can see there's a few different options for us. The ones that we are going to be concerned about today are the input action and the input mapping context. Let's start with the input action. I'm going to call this IA for input action _ move, and then I'm going to open that up. This is going to represent our movement as an input action or as a player made action in game. Not much setup actually needs to be done inside of the actual input action. Way more gets set up inside of the input mapping context. But what we do need to set up here is the value type. Let me show you what this looks like. So currently our IA move is set to have a value type of Boolean. That means true or false. If we look what this looks like inside of blueprints, we can see this action value is of type Boolean. If I go ahead and switch this to be an axis 1D inside of our player paddle, we can see this is now a float, which means it's a number. And similarly, I can also do this for a 2-dimensional vector, which changes this to be a 2-dimensional vector, and so so on. So let's ask ourselves, what do we need? If this was a third-person game or a first-person game, we'd probably want the 2D vector because we'd be moving in 2 dimensions. In our game, we're only going to be moving in 1 direction. So we're going to set this to be an axis 1D. Most often, if you're using an input like a button press, you're going to use the Boolean option. You care whether it is actively being held down or not. But for us, we care about which direction is being held down. And we're going to configure that in the mapping context in just a second. So let's go back to our content drawer here inside of our input folder, and then let's right click into the input section and load up an input mapping context. I'm going to call this my IMC underscore player actions. And let's open that up. This is where we actually do all the meat and potatoes of our inputting. Underneath this mapping section here, we can hit the plus section to add a mapping to our context. First, we have to give it an input action. For us, there is going to be some duplication because the third person template comes with input action. So what I'm going to do just to make our lives easier here is I'm going to go back to our content drawer. I'm just going to rename our IA move to be IA movement. That should be an easy enough change that we can make sure we're choosing the right one. In an actual project, you wouldn't have this duplication issue. But regardless, now we can set our IA movement to be our input action. And now we get to set up what triggers this action. You can set this up for gamepads, controllers, keyboard, mouse, whatever you want. But for today, we're just going to do our keyboard. Just to show you that things work, I'm going to start by hitting this button here and then clicking the button I want to trigger this. And I'm going to tap W because that'll be our up button, let's say. You are more than welcome to add multiple different movements here. You can set this to be the up arrow. And now on both the up arrow and W being pressed, we are going to receive input. What input are we receiving? We are using a one-dimensional float, which means we're going to receive a value of 1 whenever we are holding this button down. So let's take a second to actually set up this input mapping context in our paddle. If we go into our player paddle, we're going to scroll up and look at this BeginPlay method here. Right click to get the controller. From there, we need to make sure this is actually our player's control. So what we're going to do is we're going to do something called a cast to player controller. Connect that there. Casting basically makes sure that what we are passing in is the object that we are specifying. So we are getting the controller that controls our player paddle. And if it is a player controller, then we are going to take this branch here. If it is not a player controller, then we would take this branch here. And then with this confirmation that this is a player controller, we're able to use player controller methods by using this third option here. So we're going to get something that's stored on our player controller called the enhanced input local player subsystem. And we're going to be paranoid and we're going to make sure that this is valid. And the way we do that is we type is valid and we take the question mark one and we're going to say, is this input system valid? If it is valid, we're going to add a mapping context. What mapping context are we going to add? Well, we get to choose from a drop down and it's going to be our player actions that we're setting up here. Don't worry about priority for the purposes of this project. Sometimes there's multiple input mapping contexts. So then from there, this little blurb of code here is what actually sets up this paddle to be able to receive input. Then from there, this input action is now able to be called because we have our mapping context. So if I drag off of this and do print string, then I can connect our action value so that we print the value that is being returned when we press a button. And I'm going to use this to show you a couple of things. When I hit play here, you can see we're still controlling that third person pawn. So first we have to make sure we're controlling a paddle. The way we're going to do that is we're going to go to edit, project settings. Then we could go to maps and modes. And we can see here that the default game mode that is being used is this BP underscore third person game mode. We need to find this in order to change it. If we do want to find it nice and easy, we can hit this little button here that allows us to instantly browse to that asset in the content browser. We can now close our project settings and we're going to open up our third person game mode. Inside of the third person game mode, there is a whole bunch of default classes that are shown here. Our default pawn class is currently set up to be the BP underscore third person character. We need to change that to be our BP underscore player paddle. Now, instead of spawning in that human, we're going to spawn in our beautiful gray block. And now when I go back inside of our player paddle for simplicity and hit play, you can see that we spawn our beautiful cube. And now when I hit W, you can see that we're printing that 1.0 in the top left corner. Same happens when I hit the up key. Let's talk about the differences between all of these different types of input movements. So to show this off, I've created a one-word print string that'll happen depending on the input type that is being used here. A lot of these are self-explanatory, but let's go over them. Triggered happens so long as the triggered condition is taking place. We can set triggered conditions inside of the mapping context here by looking at our triggers. If I put an element into this, we can see that we can do a lot of different things as what officially triggers the input action. But once that trigger has been met, that's when the triggered appears. For instance, if I do this hold, we can see that the trigger fires once the input has remained actuated for the hold time threshold. Let's come back to that in a second. Right now, if I hit play, when I press W, you can see that we have start, then a few frames of trigger, and then complete it. That's because when I press the button, start happens first, then after start, so long as the button is still being held, Every frame we are going to receive an input. And then once I let go of the button, the completed event fires. But you will notice that the canceled and ongoing did not. Well, let's adjust our input action just for fun. I'm gonna go and I'm gonna add this hold trigger here, and feel free, you can just look at this and you don't have to follow along. We can now add a hold time threshold of say 3 seconds. We can also say, should this trigger fire only once or fire every frame once the hold time is met? I'm gonna say that this is only gonna be one shot to avoid things cluttering up the screen. So now I'm going to hit save and I'm going to hit play. So what you're going to see here is first started appears, then we have ongoing, and then we have canceled. Ongoing is what's called while we're waiting for the trigger to take place. So I'm gonna hold this down and I'm gonna count to 3. And then you can see that we have the trigger take place and then completed. So in the event that we have a more convoluted trigger, then the ongoing event is going to be called until the trigger condition is met. If we don't meet the trigger condition and stop holding the button down, then you will see that the canceled. And let's show that one more time. So if I just press the W key, you can see we start, we have ongoings, and then we cancel. But when I hold that button for infinitely longer than I was intending to, then we have our trigger and then the completed actions follow. There is obviously more that we could get into with what all of these different triggers do, but I'll leave it up to you to read through and go into more detail on that on your own. But I hope that makes sense. The next thing we have to talk about is modifiers. We don't always want to move in the upwards direction. We would hopefully like to move down too. So what I'm going to do here is I'm going to add another binding, and I'm going to set that to be the S key. And just for being consistent, I'll also add one for the down arrow as well. But what's going to happen here is we need to add a modifier. A modifier takes the input that is happening because we are triggering an event, and then it modifies it in some way. I know, really hard stuff there. The types of modifiers that we can do definitely can be a little more complicated. The main ones that I use are swizzling and negating. Negating inverts the axis. Right now, when we're holding down this S key, we'd be returning a value of +1. But if we negate that, then we're going to return -1, which is perfect because we want to use the S and down key to move down. So we want to have the opposite effect of our W and up key. And only because I mentioned it, swizzling is what allows you to map successfully into a 2D space. If you're interested in looking at a swizzle that is working, look at the third person input mapping context that's provided by the template, and you'll be able to see what it looks like in action. But for the purposes of our project, we're going to negate the input that comes in when we press either the S key or down. So now when I save that, I'm gonna go back into my player paddle, and let's reconfigure things so that we are once again printing the action value that is returned when we're holding the button down. Let's compile, save, and I'm gonna hit play. So when I hit W, we're having that +1 return, and when I hit S, we have that -1 return. And this is what's going to allow us to actually move. But overall, that is the summary and basic overview of how input actions work. This is obviously just the tip of the iceberg, but I hope this sets you on the right path as you're going and making your own projects. So now that we understand how the input works, we're actually able to go and move now. So let's move towards doing that. If we click on our movement component here, we can see all of the details for what it does. We can see that it has a speed, acceleration, deceleration. I'm gonna leave all of these at default for now, and we might tune it later. But what we can't see is all of the different methods that this component has on it. But what we can do is we can take our movement component and we can drag it into our blueprint. Then from there, if I drag off of my movement component and have this context sensitive check mark on, that means we're only going to receive results that are relevant to our movement component. Then when I search for something as simple as move, we can see that for our pawn movement, we can add an input vector, we can consume, we're going to do a whole bunch of things related to this input vector. Well, what is an input vector? If I hover over add input vector, this says it adds the given vector to the accumulated input in world space. Input vectors are usually between 0 and 1, and they are accumulated during a frame and then applied as acceleration during the movement update. That sounds good enough for our purposes, honestly. So I'm going to add the input vector here. I'm going to clear away this print string, and I'm going to connect this triggered event to our add input vector method. But what direction do we want to apply it? Right now, this is expecting a vector, but if I right click on this, and if you right click on any vector in Blueprint, you'll be able to split the structure. Now it's 3 different floats: the X direction, the Y direction, and the Z direction. So we don't have to fill in all of them. And since we're not moving in 3 different directions at once, that's what we're going to want here. But what direction do we want to move in? If I go to my viewport, let's focus on this player start by hitting the F key here. So I'm going to highlight my player start. I'm going to hit F. And now let's look at this gizmo in more detail. Right now, we can see that this is our side over here, and we want to be able to move according to that side. So what axis does that correspond to? Well, to move up and down, we're using this red button, which corresponds to the X axis. So as such, we want our action value value to be the input vector for the x-axis. Let's compile and save that. And you can see here that we're getting an error. The movement component is not blueprint visible. It has to be set as blueprint read only or blueprint read write. Well, fantastic. What we're going to do is we're going to go back into Visual Studio quickly then. Let's go into our header file where we declared our movement component. And we can see now that we need to be able to use this inside a blueprint. So if we press comma, we can also add blueprint read only. This means that we're able to use the component inside a blueprint. We can't make changes to it. If we wanted to make changes to it, we would have to use blueprint read write. But I don't know if that's going to be necessary for our purposes yet. So just to make sure that we're always exposing as little as possible, I'm going to set this as blueprint read only. Then when I hit save and build, you'll get an error that says that blueprint read only should not be used on private members. That is something that Epic likes. So in order to adhere to that, we are going to take this, we are going to cut it, and we're going to place it in the public section. And I'm going to place that up here. So now when I hit save and build, you're going to see that we're getting an error. And I did this very intentionally because by default, if you look at the editor, which I still have open despite my own warnings, things are going to get bad. And the reason that we can't build with the editor open at all is because of this in the bottom right-hand corner. This is called live coding. If you click on this little compile options menu here, you want to disable live coding. Get rid of it. You don't need it. It doesn't work right most of the time anyway. But with that disabled, then you can at least successfully build from your compiler with the engine open. Now, again, I don't recommend this. You should close your editor. That way, when you make changes to the header file, just like we just did, things will still maybe work for you. Because at least when you have the editor closed and you make changes to a header file, you're guaranteeing that the code that you just built is actually going to work. I like to live dangerously, so let's open this up, go back into our player paddle, and you can see now we're able to compile successfully. It's like I said, the error and bug doesn't always happen, but it happens often enough that it might annoy you and cause you to lose your mind. Regardless, we've compiled, saved, and now let's hit play. When I hit W now, we can see that our character is moving. Fantastic. We now have a paddle that is going to be able to intercept a ball inside of our world. We'll be able to place them a little bit better in just a bit. So now I want to take a couple of minutes and pivot towards collision in Unreal, because right now when we hit play, we can see as we move towards our top wall, we actually don't stop. We're able to run right through our border, and that obviously isn't what we would like to happen. So let's talk about collision. When we're troubleshooting collision issues, the first thing that we should check is if our object actually occupies the right space. So if we open up our paddle blueprint for our player, we can go into the viewport and we can make sure that our collider takes up approximately the same space as our mesh. And we can see here, based off of this red outline, that our mesh and our collider are not perfectly lined up, which could cause us a few issues going forward. So I'm just going to go and roughly pan around this object here and make sure that we are properly oriented. And you can see as we change the perspective that we weren't close at all. And now that collider and our box are taking up approximately the same space, we can see that I have my box extent of 50s and my mesh at about the -50 spots. So let's compile and save that and see if that solves our issue. Now when we go forward here, we still run right through the wall. What else could be happening here? Well, the next thing we can do is we're going to actually troubleshoot the level a little bit. Maybe there's something wrong with our level. When we hit play, we can either possess our pawn and start moving around, or if you'd like, you can hit the F8 key to pop out, and then you can control everything like it was the actual viewport. This can be very handy for debugging things as you're working on your level. And you can see here that I think I'm starting to see the issue. This object, our player, is hovering above the ground, whereas our wall is touching the ground. Right now on this path, our player is going to go right over our wall, and that is obviously why the collision is not taking place. So why would our player be hovering? Well, when the game starts, our player is being spawned at this player start location. And we can see here that our player start is at location 0095. And when I go and hit play again and I pop out with F8, I can click on my player and we can see that they inherit from that baseline. We can see here that we are floating in space 180 units above. So let's pop out, look at our player start one more time, and let's just zero this out so that it's at 000, or the point of origin. Now when I hit play, and if I hit F8, we can see now that our location is pretty much 000 here as well. So now if I hit this little control pad, that lets me attach myself to control my player again. And when I go up towards the wall, you can see I stop. Now, if this also doesn't work, there is a possibility that you don't have collision set up on the mesh or collider. So let's look at our player paddle one more time. Both the collider and the mesh can both have collision on it. Let's start with our collider. If we type in collision, you're gonna get collision settings here. And you wanna make sure that your collision preset is set to block all. And we're gonna talk about what these collision presets are in just a second. Now, since your collider is doing the collision, we want our mesh to exist in the world, but not actually interact with anything. collisioning. So looking at the same settings for our mesh, we want to make sure our collision preset for the mesh is set to no collision. Similarly, we're going to need to do the same check on our wall. So if we open up our wall blueprint, go into our static mesh component, and look for the collision, we can see that our wall should also be set to block all. But now with all of that being said, what the heck is collision in Unreal looking for, and how do we manipulate it? My current understanding of collision for Unreal is twofold. We rely on the object type and the response channel. You'll notice that this is all grayed out on our current object, and that is because we have determined to use a preset. If we change our preset to be custom, then all of a sudden all of this is going to be interactable for us. So what the heck does all of this mean? Every object has an object type. This is what kind of object this object is going to be in space. There are so many to choose from, and you can add your own if there's nothing here that specifically fits your needs. For instance, world static represents objects that are just staying still in the world, whereas something like a pawn would represent our player that actually moves around the world. Each one of these object types can and will have different responses depending on what they're running up against. The three types of responses you can have are ignore, overlap, and block. When two objects intersect, they're always going to use the least offensive response. Ignore is always the least responsive, overlap is in the middle, and block is the most oppressive. If two objects are both set to block, you can't pass through. If one is set to block and one is set to ignore, well, then that ignoring object will be able to phase right through. And what makes this powerful is we can choose either on a per object basis or on a preset basis what we would like to interact with. If I change this to be block all, we can see that we are choosing ourselves to be an object type of world static, and we are going to block every single object. That means that any other object that is also going to have block is going to be blocked by this wall. To drive this point home, I'm going to show you a few examples. This is a sample block that I've placed in the scene, and based off of its collision settings, we are currently setting it to block all. And as we know from our player is also set to block all. So when I join the game and I run towards this block, we phase right through. And the reason we phased right through is because, again, we have to make sure that our objects are lining up with each other. This block was not properly placed. Let's put it up into the world, and now let's hit play again. And now we are actually properly blocked. And you can see here, based off of this little cheat that I made, that an event is able to be fired when we hit something. So if we look at our player paddle, we can see here that when our object is hit, we print a string. And we can use this to do a whole bunch of things because we get a whole bunch of useful information with this event, such as the other actor or the other component that is involved in the collision. Similar things can be done with overlap. If I change this collision preset of this block away from block all and set it to overlap all instead, now when I hit play, I'm going to phase right through this block. And you can see that that on hit event no longer is firing. That makes sense because we're taking the least offensive option, which in this case is overlapping. And similarly, if I set no collision, then everything is going to be ignored. And then when I hit play, I can phase right through once again. And just for the sake of completionist here, if you go to Edit, Project Settings, you can go to this collision section right here under Engine, and then you're able to look at all of the presets and make any changes you would like. Even more to that, you can add a new preset, and you can also add new objects and new trace channels. This can allow you to further customize any project you're working on if you have specific functionality that might not fit into any of these predetermined molds. And I will also add that you don't have to do this just in Blueprint. Inside of the C++ file, you're able to actually assign the collision preset of anything that you would like. So for instance, if by default we want our collider to be blocking everything and our mesh to ignore everything, we could do that. We can do that by going collider, and then we can do set collision profile name. And then when we open up our parentheses here, we can see that it needs an F name that takes in the profile name. So we can create an F name variable, and we know that the collision preset that we want to use here is block all, case sensitive. And we can do something similar down here for mesh, except we want the name to not be block all, we want it to be no collision. So now this sets up the default for our paddle to use different collision profile names. That stops us from having to manually do it every time we create a blueprint. So let's save, compile. But that is the absolute basics of collision in Unreal, and that's all you should need to know for us to understand what we're about to do with our ball, because we need a ball that's going to bounce around and do something whenever we hit a wall or a paddle. So let's create this ball now. What we're going to do is we're going to create a new C++ class. So you can go into the C++ classes folder, open up your folder, right click, new C++ class. This time we're going to choose our ball to be an actor because we don't actually need to control or have a controller give anything to this ball. It's just going to walk around bounded bounds. So an actor that can just be placed and then manipulated in the world is plenty for our purposes here. I'm going to call this ball, and then I'm going to hit create class. Now, almost immediately, this new file is going to be created and appear within Visual Studio or your code editor. But there we go. You have to be patient. The game is going to recompile itself to use the changes of this new file. And if you start just making changes willy-nilly, you'll lose it when this file modification detected comes up. Just wait for this to come, hit reload all, and then everything is up to date for you. So now that the game is recompiled and we've reloaded our Visual Studio, we're going to start making our ball. What does our ball need? Well, we're going to need something that's going to dictate how fast our ball is going. We need to do something when we hit the ball or the paddle. And besides that, we're going to need both a collider and a flesh suit. So let's start chipping away at this. Let's start with some speed variables. Remember, if you go underneath generated body, these are going to be treated like private variables. In line here, I'm going to create a new UProperty, and this is just going to be edit defaults only, because we don't want these variables to actually be adjusted on the fly, but we want to use them in our code. And this is going to be a float, which basically represents a number with decimals, and we're going to call this our current ball speed. And let's just say it starts at 5. Due to the lack of a semicolon here, the IntelliSense does freak out a little bit. Just force the issue, and then once you've done the first variable, it no longer will be a thing. Then I'm going to copy this for ease of use, because I'm also going to make a second float variable, and this is going to be called my starting ball speed. And then I'll make a third variable, also a float, that I'm going to call my ball speed up increment. And let's call this starting at 3. Our starting ball speed is pretty obvious. Our current ball speed is going to be what we use to actually move our ball around. And then our ball speed up increment is going to be how much faster our ball gets every single time we hit something. Now, inside of our public section, let's go and create our components and the things we're going to need. The mesh is exactly like it was before. So we're going to make a UProperty. This is going to be of type U static mesh component, and it's a pointer, so we use the asterisk, and then we say mesh as the name. We're going to make another UProperty, this time for our collider, and this is going to be a UCapsule component, also going to be a pointer, and this is going to be our collider. Now you'll remember that these red squigglies are existing because we need to forward declare. So let's use our keyword class, and then it trusts us to deal with this inside of our C++ file. Fantastic. So let's go into our ball now. And first we need to fulfill our promise. So let's do an include here. And we're looking for the capsule component. A lot of the time components are held in this components folder. And let's see if capsule component appears. It does. There we go. Didn't even need to Google it this time. So now with our includes sorted out, we're going to go into our constructor and we're going to build those components. Just like before, collider is going to be our boss, and collider is going to equal a create default subobject of type UCapsule component. And it's going to be called our collider. Just like before, our root component is now going to be equal to our collider. And what do we want our ball to do here? Collision wise, we want it to hit absolutely everything. So we're going to set our collider, and we're going to call off of that to set up our collision. And our profile name is going to be an F name that we know is called block all. Now for the mesh. Mesh is going to equal a create default subobject of type UStatic mesh component. And we are going to call this our mesh. And to make sure our mesh follows our collider around, we're going to do mesh, and then we're going to call a method off of that called setUpAttachment. And we're going to make sure it follows our collider, or since it's the same thing, we'll follow our root component. I'm going to hit Control-Shift-S, Control-Shift-B to build. And now inside of my editor, I'm going to right click on the ball C++ class, and I'm going to hit create blueprint. And I'm going to call this BP_ball because naming conventions. I'll say that's in the content folder, and this opens up our new blueprint. And you can see here we have our capsule collider and our mesh. Let's do something nice and simple here. Our static mesh, let's just make it a nice sphere. I'm going to do the control rig sphere. Doesn't look too big. And then I'm going to adjust my collider by increasing its half height until I can barely see it up top here. And then I'm going to expand my capsule radius until it's as much as it can go. And then just for simplicity, I'm going to even out both of these to be a nice 50 on each variable. And you can see that it pretty much perfectly encompasses the sphere. And then let's delete this cube we had from earlier. Let's zoom out a bit and let's place our ball in the world here. And let's scroll down and let's make sure that it's properly placed. Our ball looks pretty good, all things considered anyway. Now, I'm going to teach you a new way to move an object around. This can be done in code or in Blueprint, but I'm going to show you in code. Inside of the tick function, we can do things that happen every frame. So every single frame, we're going to be able to do something. In the same vein, BeginPlay allows us to set up variables that start when the game starts. So for instance, something that we should do here is have our current ball speed equal to our starting ball speed. That way, whenever we're starting the game, our current ball speed that we're going to use to move our ball around is equal to whatever value we think is a good starting speed. Now from there, we're going to need some sort of direction. Where is our ball going to travel? Let's set this up as a variable. Back in our header file, let's create another variable here. We'll make it a UProperty. And this time, I'm going to say that this is going to be visible anywhere. This means we're going to be able to see it. So for the purposes of debugging, we're going to be able to know what is going on, but we're not going to be able to edit it or use it inside of the blueprint. And this is going to be a F vector type. A vector vector is an X, Y, and Z coordinate system that allows us to either set a direction or a point in space depending on the context that we're using it. In this context, we're going to be using it for a direction. I'm going to call this my ball direction. Now, inside of our begin play, because when the game starts, we'll want to initialize this variable, we're going to set our ball direction to be equal to a new F vector that is going to be 0, 0, and 0. So in other words, we're saying it's going to go nowhere. So now let's decide which way we want it to go. If we look at our world, we know that this red X coordinate represents up and down, and we know that this green Y coordinate represents left and right. When the game actually begins, we're going to have a player over here and a player over here, and we want to send the ball towards that player. Nice and easy, kind of like a little lob for serve. So for the purposes of direction, we're going to send our ball either in a positive or a negative Y direction. And since we don't necessarily care which way, we're just going to hard code it, and it can always go that way. And let's say it'll always go towards the player. So if we take our player and make them stand over here, and we look at our ball, get rid of our filter, look at this location variable, as we move to the left, we can see that Y coordinate is getting more negative. So we're going to send our ball to the -1 in the Y direction. So inside of here, I'm going to change this to now be -1 in the Y direction. And now when we use this ball direction variable, we'll be confident that it's going to fly towards our player. Now, every single frame, we are going to move our ball a little bit. As such, we are going to use the tick function. Inside of the tick function, we get an input parameter called DeltaTime. DeltaTime represents the amount of time that has passed between frames, and we use DeltaTime in order to make sure that things run consistently machine to machine. My computer and your computer are not going to have the same frame rate running this game, but we can have the same experience if we use DeltaTime. So what are we going to do here? Let's create a new F vector variable that I'm going to call our new location. What is our new location going to look like? Well, we should take our current location and then add our speed and direction to it. That's easy enough to do. We can get our current location by calling a function called getActorLocation. That gives us our current location. Then from there, let's add some math. We're going to take our ball direction, which is an F vector, and we're going to times that by our current ball speed. So if you take a vector and times it by a float, then everything inside of the vector is going to have that float multiplied by it. So it would be 0 times 5, -1 times 5, and 0 times 5. But since we want this to be frame rate independent, we are also going to multiply this new number by DeltaTime. This way, everyone will have a consistent experience. So we've found where we want to go. Now we just need to put our character there. Let's do SetActorLocation, and then let's set ourselves to go to that new location that we just created. I'm now going to hit Control-Shift-S and then Control-Shift-B to build. Our build succeeds. We can go back into our editor, and now let's see what happens when I hit play. You can kind of see it, but it's moving really slowly. Let's get dramatic. Instead of our blueprint for our ball, if we click on the BP_ball self at the top, that is what's going to give us access to all of those U properties that we were creating. In the details pane on the right-hand side, we can see we have our current ball speed, our starting ball speed, and our ball speed up increment. Let's get dramatic. Our starting ball speed is going to be 1000. Let's compile and save and then hit play here. Now we can see our ball is actually moving. But bad news, it didn't stop at the wall. Why is that? Well, that is actually a quirk of using this SetActorLocation method. It, in its default form, is not going to check for collision, but luckily we are able to force it to. If we add a second parameter and use a different version of the SetActorLocation method, we can include this second parameter here, which is the bsweep. This means, do you want me to check for collision? Right now, you can see that by default, if we do not specify, then bsweep is going to be equal to false, which is why we didn't detect any collision there. But if I say true, as in I do want you to check for collision, and then I hit Control-Shift-S, Control-Shift-B to build, when I switch back to my editor now and hit play, you will see our ball kind of starts freaking out a little bit. But why would it be freaking out? Realistically, it's because the ball is touching on the bottom here. Something else that's interesting about this SetActorLocation method is if I hit comma to try and add another parameter here, you can see that it is not going to teleport. Therefore, if we're hitting that collision, we are not going to be moving anywhere. If I go back into my editor and I raise this up just so that it's not directly touching the ground, and then I hit play, you can see our ball moves, it hits the wall, and then it stops. Perfect. Now we're ready to talk about collision events. A collision event is something that happens when something hits something else. If you remember from before, inside of my paddle, this is an example of a collision event. When my collider on my paddle hits anything, I'm going to print a string. And we can see that in action when I hit play and I run towards my wall and I hit that wall. We can see hello gets printed. Perfect. But what if I want to do something custom? We can do a whole bunch of stuff within blueprints. We could add sounds, effects, really a whole bunch of stuff. But sometimes we just want to take full control of the situation and make something ourselves. The reason I'm bringing this up before we go into code is I want you to look and see all of the things that we get on a hit event. We have a hit component, which represents the component on your actor that got hit. We have the other actor, which represents the thing that hit you. We have the other component, which represents the component that hit you. And then we have an impulse and the hit result. If we break the hit result up, you can see you get a whole bunch of information, a whole bunch of things that you could do depending on what has hit you. I bring all this up to say that creating this exact signature inside of C++ can be a bit of a pain, but we can remove the dependency of having to do things automatically because we as a designer want full control in Blueprint of what happens when we collide with something. Therefore, if I go into my code and we're looking at our ball here, I can go into my header file, create a new public something, and then with magic, we can connect it in the blueprint so that we don't necessarily need to give all of those variables to whatever we're using. We can simply stick to what we want to see. So let's talk about the magic then. The magic in this case is a special word called UFUNCTION. UFUNCTION is the function or method version of UProperty. It has different signifiers, but the ones that we're going to use the most often all have to do with how can I use this in Blueprint. For instance, if we want to use a specific method and have its code run in blueprints, well, that's going to be blueprint callable. The return type for this method is going to be void because we don't want to return any specific piece of information. And I'm going to call this OnBallHit. Now at this point, we need to decide what do we care about. Honestly, I think the only piece of information I care about is what hit us. If we flash back to the blueprint, that gets given as an actor. This is an actor object reference. So to make things easy on ourselves inside of code, we're going to make an actor reference, which is an actor pointer that we're going to call other actor. So this is going to be what we're eventually going to connect to our event in our balls blueprint. I'm going to quickly create this in my C++ file with Alt-Enter. And now let's think to ourselves, what do we want to happen when the ball hits a wall or a paddle? Well, in general, we want to increase our ball's speed and we want to turn around. Increasing our ball's speed is easy enough. We can just take our current ball speed and then plus equals, as in add this to myself, the ball speed increment. And then to actually flip ourselves around, well, it's going to depend on what we hit, isn't it? If we look at our world here, if we go to the left and we hit a paddle, we would expect the paddle to send us in the other direction. But again, that's fixed on the Y. Even if we're coming in at an angle here, if I hit my paddle here, I would expect that angle to be consistent, just going the other way. But if I hit a wall on the bottom here, I want to keep my Y momentum, but switch my X. So we care about what we're hitting. So what we're going to do is we're going to check to see, did we hit a paddle or did we hit a wall? To do that, we need to cast this other actor and see if it's successful. What are we going to cast to? Well, we're going to see if it's a paddle. So we need to include paddle.h at the top of our ball so that we can actually use our paddle. And then inside of our OnBallHit method here, we're going to make an if statement. And we're going to say if the cast to a paddle on object other actor is successful, then we're going to do this code. So we'll do something and then we'll return. Therefore, if we get to this part of the code, we couldn't have hit a paddle. So let's go back to our level here for a second and let's go over that one more time. As our ball comes here, if we hit a paddle, we want to switch the way we're traveling in the Y direction. So inside of our code, if we hit a paddle, then our ball direction dot Y is going to equal the inverse of ball direction dot Y, as in we're going to flip it. But if we hit a wall, we're going to do the same thing, but with the X coordinate. We're going to flip ourselves on the X axis. Let's Control S and then Control Shift B to build. We can see the build is successful. So when I go and hit play here, it'll be a little bit weird trying to catch this, but you can see we get our hello firing, but the ball still keeps charging forward. What the heck gives? Well, this is where you have to remember that you have to connect things. So if we go into our ball blueprint and we go into our event graph, we now need to set up that event to actually fire and use our code. So if we go to the top left corner, right click on Collider and add an event, we can do add on component hit to our ball. So now what do we want to happen when we hit something? We want to do on ball hit. This has all of the logic and everything we need, and this is what we just coded. But what do we need to pass in? We need to pass in the other actor. So we just connect that like so. And now when our collider hits something, we are going to call the method that we created in C++ to handle the ball hitting something. Now when I hit play, let's get in the way, and you can see it flips direction. Look what happens when we hit that wall. Absolutely nothing. Why is it doing nothing? Well, that's because that's how we coded it. We're only switching the X direction when we hit a wall, but we can't switch the X direction if the X direction is set as 0. The inverse of 0 is still 0. Let's change our X direction here to be +1 so that we actually move in the X direction, and then let's save and compile that. Now when I go and hit play, you'll see that our ball successfully bounces bounces off the top wall, but it still has a bit of difficulty when it hits the side wall, but that's okay because in just a little bit we're going to be scoring. In fact, let's start setting up the scoring stuff now. We're going to implement scoring by having a trigger volume next to each side wall. It will then be responsible for incrementing the score of a specific paddle that happened to score the goal. We're going to do this in 3 different parts. First, we have to give our paddle a score variable that our score zone can actually see. Then we need to create the score zone, which will have an event that occurs when an overlap takes place. And then during that event, we're going to look to the paddle that we represent, give their score a nice +1, and then reset our ball to its original position. Let's start by giving our paddle a score variable. Let's go to the paddle's header file and go to this public section here. The reason we're doing public is we need the score zone to be able to see it. This is going to be an integer that we are going to call the score. For debugging purposes, I am going to make this a UProperty, but we don't actually want to interact with this at all. We just want to see it. So what property is that going to be? Visible anywhere. Now our score needs to have their value reset whenever we start the game. So let's go into our C++ file, go to the BeginPlay method, and then add this line where we're going to set our score to be equal to 0 whenever the game starts. So now let's talk about resetting our ball. When our ball reaches this scoring threshold, we need to have something that's going to reset it back to the middle or where it starts. As such, we need to have some sort of value on our ball that is going to be taken in and absorbed whenever we start the game. That way, when we do reset our ball, we're going to have a reference point already on our ball that we can use. So let's go to our ball's header file here, and we're going to make a new private variable. We don't need anyone to see this. This is strictly going to be used inside of code. And then inside of the C++ file, let's go to the BeginPlay method, and we're going to set our initial position here to be equal to the getActorLocation method. So wherever we place this ball in the viewport, it's going to be placed inside this initial position variable for us to use later. But now we need the actual method that's going to do the resetting. So let's go back into our header file, go to the public section since our score zone is going to be able to know about this. And let's create a new void type function because we don't need anything returned and call this our reset ball. Using Alt Enter, I'm going to create this inside of my C++ file. And now let's think about what we actually want to do here. First, we're going to need to reset our ball's position. So we're going to set our actor's location to be equal to that initial position variable that we've just finished setting up. Next, it's probably important for us to reset the ball's speed. Remember, whenever we hit something, our ball's going to be going faster and faster. This reset function is going to be a great place for us to, well, reset that speed. And honestly, I think that's all we really need to do to reset our ball. So let's Control-Shift-S, Control-Shift-B to build everything that we've just changed. And with no errors, we're good to actually set up our score zone object now. So now we're ready to actually create the score zone that's going to do everything that we just created. So let's go into Tools, New C++ Class. And for this, we're going to want to choose actor because we only care that it gets placed in the world and does its job. For the name, I'm going to name this ScoreZone, and let's create that class. Once everything is compiled and reloaded, let's think about what we actually need here. This is not the most complex object we've ever built, but we are going to need some sort of box component that exists in the world that will be able to trigger our overlap event. The next thing we need is a function that will be called whenever the overlap happens with an object in the world. Let's make a new function that's blueprint callable, and let's call this our score overlap. Now, we don't need this to return anything, so void is fine, but what do we need to be passed to us? Realistically, the only thing that should ever intersect with us is our ball. But we are going to play it safe and make sure, so let's make sure we pass in that other actor whenever we start this function. Now, the last thing we need is that reference to another paddle that exists in the world. And there's a special new type of UProperty argument that we're going to show off here that is very expansive. But in terms of where we want to see this, we want to be able to edit and use this anywhere, so we're going to use edit anywhere. We're probably going to want to use it in Blueprint as well, so let's use Blueprint read write. And now let's talk about this new special operator. It's called meta. There are several meta tags that exist, and I will leave the documentation down below just so that you can go and review, that each do very specific things. For our purposes here, we want to use or have reference to something specific that exists in the viewport. As such, we're going to use the meta tag expose on spawn, and we're going to set that to be true. So now we're going to forward declare a paddle reference that I'm going to call our scoring paddle because this is the paddle that we want to interact with when they score. Now inside of our C++ file, we're going to start by adding those include statements. Our paddle C++ actually has everything that we need out of the box. It has both the paddle header file and the box component header file. So let's just copy and paste those in. Inside of our constructor, we only have the one component that we care about. So let's create that the same way we created the other ones. Our score zone is equal to the create default subobject of a box component component, and I'm going to name it the score zone. For simplicity, I'm also going to make our root component equal to our score zone. Now, what type of collision do we want for our score zone? Based off of everything we've talked about so far, we would like this to be an overlapping object. So we have to make sure our score zone is set to use the collision profile name overlap all. Now we're ready to talk about what we want to do when the overlap takes place. In general, our overlap function is going to first make sure that the ball is what actually intersected with us, and then if it was, we are going to give our paddle a nice boost to their score and then reset our ball's position. In order to use the ResetBall function we created on our ball, we are going to need to include the ball header file into our score zone so that we can use those functions. Now let's worry about the function itself. Due to how we set up our overlapping function, we know we are going to get the other actor involved in this event. Therefore, to verify that the other actor is in fact a ball, we are going to perform a cast. With this line here, we create a variable called our ball reference, and we are setting it to be equal to the cast of the other actor towards a ball. If this succeeds, then ball reference is going to be a ball because other actor was the ball. But if something else overlaps with our score zone, then this will be null. Because of this, we can actually use the ball reference inside of an if statement and say if ball ref. This is asking, is the ball reference null? The ball reference will not be null if the other actor was a ball. But that's not the other thing we should make sure exists. We should also check to make sure our scoring paddle exists, because there is many a scenario where you or me just forget to set our scoring paddle inside of the editor. If we do that, we don't want to throw a null pointer exception by trying to use a paddle that we haven't set up. The way to avoid all of that headache is to set up an if statement that makes sure that the scoring paddle is not equal to null. This also makes it really obvious when we're playing the game, because if something is broken with scoring, we're at least going to start looking here at this score overlap event, and then that will help us narrow in on the issue. So if all of that clears, we're going to be good to increment our scoring paddle's score. And the way we're going to do that is we're going to take our scoring paddle object and use that variable that we found called score. And we're going to increase it by 1 by using ++. After that is done, we have to reset our ball's position. And we're going to do that by taking our ball reference, which is already properly set up and exists in the world. And we're going to call the method off of that we created earlier called ResetBall. From there, I can hit Control-Shift-S and then Control-Shift-B to build, and we can see that we have no errors. So let's go back into our editor and finish setting this up. We can right-click on our ScoreZone C++ class to create a new blueprint. I'm going to call this my BP_ScoreZone, and I'm going to store this in content. When this opens, we can see that, as expected, we just have our one overlapping collider zone called ScoreZone. And if we highlight this self in the top left-hand corner, then we can see that scoring paddle exists. But it's not going to be much use to us now because we do not have our viewport as a frame of reference. But let's at least go into our event graph and make sure that when that overlap takes place, we use that method that we created inside of code. So on component begin overlap for our score zone, we are going to use the score overlap function, and we are going to pass in the other actor that was involved in this overlap event. From there, we can actually set up the score zones in the world. So let's drag in a score zone, and we'll use our resize tool, which is the R key, and then we're going to make it nice and long, and we'll make it a little bit wider, and we'll just slide this into place using our move tool, which is short key W. From there, I'm going to duplicate this by holding my Alt key and dragging with the move tool, and then I'm going to make a second score zone on that right-hand side. From there, just to set the scene and to fully illustrate what's going on here, I'm going to drag in two references of a player paddle. We'll place the first player paddle on the left and the other on the right. Now, when we hit play, we can see something weird happens here. We now have two player paddles that are existing on the left-hand side. That obviously isn't expected. The reason that's taking place is if you look closely here, we can see that we have both the player paddle that we just placed and that player start, which is going to become the player paddle when we start the game. To fix this, we are going to force the issue and basically force our player to become the placed player paddle rather than the one that gets spawned in. So the best way to do that is we are going to delete the player start, and then with the other player paddle highlighted, we're going to go into its details on the right-hand side, and we're going to auto-possess player 0, which is a very similar approach to what we did with the camera. So now when we hit play, we can see there is only the one player on that left-hand side, which is very good, but we can also see that our ball is still not triggering our score zone. Well, that goes back to the logic that we set up, because we said if we forget to set up our scoring paddle on the instance of this score zone, then we're not going to do anything. And almost as if I spoke it into existence, I also forgot to set that up. So let's go into our score zones, and then we have the ability to edit the scoring paddle variable on each individual instance. And that's what that expose on spawn meta tag does for us. Now from there, we could hit this little drop down and it'll bring up every single paddle that is applicable for use in the scene, or we can use this little eyedrop tool here to pick an actor that exists in the scene. And that's what I'm going to do because that lets me get real specific. So which player scores if our left score zone has the event? Well, that would be the player on the right-hand side, because they're the one that would have shoved the ball this way. The same is true when we set up the right score zone. Now when we hit play and we let that ball through, we can see that the ball successfully resets its position back to the middle. And if I pop out using the F8 key, we can then click on the paddle that is doing all the scoring, and we can look at their score variable to see that it is successfully incrementing, which is perfect for this stage in the game. So now we're going to do some housekeeping and finish up with the paddle. The main thing that I want to accomplish here is I want our paddle to take on a much thinner paddle-like shape. So let's open up our player paddle blueprint here. And then in order to see what changes we're making in the world as we go, I'm going to drag this so that I can see both my blueprint editor and the world at the same time. So now inside of my blueprint editor, I'm going to go and I'm just going to adjust the size, and luckily the X direction seems to be the one that needs to be adjusted to make our paddle longer based off of the orientation we have in the game. And then to make things thinner, I'm going to thin out that Y axis to about, let's say 0.3. And honestly, I think I want the paddle a little bit longer, so why don't we do 3 in the X, 0.3 on the Y, and then we can leave the Z axis the same because it's not the most impactful with our orthographic camera anyway. Now from there, we're going to need to adjust our mesh's bounds as well. But what's interesting here is we don't actually need to do anything. In fact, our mesh was being adjusted in real time along with our collider, and that is the power of having this parent-child relationship. Since our mesh is attached to the collider, that work's already done for us. But I think it would be important for us to at least add a little splash of color to this paddle so we know which is us and which is the enemy. So we can go into the details here, and we can adjust the material on this static mesh to be this nice blue material. Now this is looking a lot better. But now when I hit play, you can see that our character is casting a shadow, and honestly that's a little bit disorienting. How can we turn off shadows? Let's go back into our blueprint. Now remember, properties and details are context specific. So if I select the BP_player paddle self at the top left, and then go to the details and look for something called cast shadow, you'll see that I get no results. But if I select the mesh component on the left-hand side, all of the details are going to change to the context of that mesh. And since the mesh is the one that's actually casting the shadow and reacting to the light in the game, this is where we need to turn off the shadow from. So we can disable the cast shadow boolean here. And then when we go back into game, you can see that our paddle is no longer casting a shadow, which is great. But of course, as we test around, you can also see that we have a new problem. Our paddle seems to almost catch the ball depending on how it lands on top of that paddle. That is not in good taste. How can we fix this? If we take a look at this specifically, it appears that the ball is just getting stuck inside of our paddle when it's trying to change directions when it hasn't gotten the most flattering angle on the paddle. So what we could do is we could adjust the collision settings as a part of our OnHit event to make it so that our paddle no longer collides with anything for a fraction of a second after our ball hits it. Let's do all of this in Blueprint so you guys can get a feel for visual scripting as well. First, I'm going to recollapse this hit result by right-clicking and then combining that structure pin back so that's a little bit easier to manage. And then let's start building. The first thing we need to do is check to make sure that the ball is what hit us, because we could also collide into walls, and we definitely don't want to stop colliding with stuff when we hit a wall. So let's check to make sure the other actor is a ball. And this is the exact same process that we follow when we're doing it in C++ as well. If our other actor is a ball, then we're going to be able to take this top node here. And in that case, we're going to want to take our collider and turn off collision. We do that with the set collision enabled node. And you can see here that we're setting the new type of collision to be no collision. But you can see here when I hit compile, we get an error. And it's specifically saying that the collider is not blueprint visible. So to fix that, we have to go into code. Inside our code, we just need to change the properties of this UBox component such that we can actually change it or use it inside a blueprint. If we wanted to both use and change, we would have to use blueprint read write. But since we just want to use it, we can settle with blueprint read only. But then when I hit Ctrl+Shift+S and Ctrl+Shift+B to build this, you can see that we get a build error. It's specifically saying that we cannot have a blueprint read write variable inside of the private section. That itself is rather easy for us to deal with because we can just cut and paste this component and move it up into the public section. So now when I resave and rebuild this code and flip back towards our blueprint, and then I try to recompile that blueprint, you can see that error goes away. But this only solves half the problem. If we left everything as it was right now, our ball would only be able to hit our player paddle one time. That obviously isn't ideal. So we're going to use a delay node. The delay node does exactly what you think it would do. It's going to wait for the duration specified, and then only after that duration is done is it going to continue the code. Now, we don't need a very long amount of time here at all, so this 0.2 seconds is going to be plenty. After this delay is completed, we are going to go into our collider and re-enable that collision. So let's just copy and paste those two nodes from before, and we'll change the new type away from no collision, and we'll let it be this this collision enabled for both query and physics, which is a pretty standard way to basically capture as much collision as possible. With all that connected, we can compile and save our new paddle, and let's see what happens when we hit play. This definitely solves the problem, but it does create a new problem. After we hit the ball, we have a 0.2-second window to clip through the wall. That's not ideal, but due to the power of our event, we're going to be able to interact with the ball and change its collision type instead. This will allow our paddle to be a constant force in the world, while allowing our ball to phase through our paddle. The way we can do that is by accessing the other component involved in the collision and changing its collision to go and disappear, and then re-enable that collision after our delay is done. And now with one final test, if I wait for the perfect opportunity and hug this top wall, you can see as the ball bounces off of me, I no longer clip through this top wall, which is, of course, the most ideal we could ask for at this point. Next, we're going to make our enemy paddle actually do something, because it's not very engaging to just need to hit the ball one time and then just have everything else happen. Unreal Engine does have great tools for creating pretty complex AI stuff. We don't need any of it. All we need is for the enemy paddle to go up and down depending on where the ball is. And then from there, since we already have a movement component on our paddle, we'll be able to set the difficulty of this AI based off of how fast we allow our movement component to go. But more complicated than that, we just finished creating this nice on-hit method for our paddle. But this is specifically on the blueprint and won't follow along if we were to just make a new instance of the C++ class. Luckily, that parent-child relationship that exists inside of C++ also follows towards blueprints as well. So if I look at the class settings here, we can see that the parent class for this player paddle is the paddle C++ class that we created. But this player paddle can also be the parent to the enemy paddle. And then the enemy paddle can use all of the stuff that exists on this blueprint. So to create a child of this player paddle, we're going to navigate to that proper section on our content browser. We're going to right-click on our player paddle, and we're going to hit Create Child Blueprint Class. That creates a new object that I'm going to call BP_enemy paddle. And now let's open that up. The first thing I'm going to do is I'm going to change our enemy paddle's color. Let's just make it this nice red color here. That way we have blue versus red, a tale as old as time, really. And then from there, if we go into our event graph, we're going to see that everything relies on the base event that we're used to seeing at this point, and then this parent BeginPlay. This is an explicit call to go back to the parent or to our player paddle and then run whatever they have during BeginPlay. Sometimes it's necessary to run what the parent has, sometimes it's not. But in this case, it is going to be, because anything that we have in the parent BeginPlay is going to cascade all the way up to that C++ file. Anywho, what do we need to do here? Well, we need to keep track of the ball, and then we need to follow the ball around. Inside of our paddle, if you remember, our movement input, we are going to be adding an input vector based off of whatever movement we're detecting. And we're going to do something very similar here, but based off of where the ball is in relation to our enemy paddle. First, we're going to need a variable that can keep track of where our ball is. On the left-hand side, under this variables tab, you can hit the little plus button to add a new variable. I'm going to call this my ball reference, and I'm going to change its type to be the ball. We're going to take the blueprint version of the ball because that is what actually exists in our game world, and we want that to be an object reference. From there, on the right-hand side for the details, we're going to click on this expose on spawn parameter here. This should sound familiar because that's the exact same thing that we enabled as a meta specifier for our score zone. So when we place our paddle into the world, we're going to be able to assign this variable to the ball that is also placed in the world. So what do we want to do? Every frame, we're going to want to adjust our position. As such, we're going to work in the tick method here. First, we need to make sure that we have actually set up our ball reference. So if we drag our ball reference into our scene, we are going to drag off of it and type is valid. This is going to make sure that the ball reference isn't null, and we can connect that here. Let's start with something simple. If our ball is valid, then we're going to want to set our actor location to be equal to wherever the ball is. So we can do that by dragging off of our ball reference and then saying get actor location, and we can just plug that in here. So now if I compile and save, you can see here we're getting this warning down here. Our ball reference is marked as expose on spawn, but it's not marked as instant editable. If I click on my variable and then look over here, you can see we also need to check this instance editable. That way it's going to be publicly editable on the instance of the blueprint. We check that, we compile, and we no longer have that warning. Now I'm going to delete the one on the left-hand side because that's how our game is oriented, and I'm going to drag in my enemy paddle. From there, in the details section, I'm going to set up my ball reference to be my BP_ball that's in the middle here. Now what do you think is going to happen when I hit play? Exactly as we expect, the ball is now floating around with the paddle. That is not really what we want. Let's take this up a notch. Just like with our original paddle movement, we don't want to follow it around directly. We only care about the x-axis. Just like we did before, if you right-click, we can split the struct pin, and now we can control each axis individually. And we can do the same thing with the return value of the getActorLocation. And now we can just set it so that it only follows it along that x-axis. Let's see what this looks like in comparison. Okay, that's better, but why are we in the middle of the screen for some reason? Well, that's because the new location Y and the new location Z are both set to 0, 0. For this approach to work, we need to get our actor location, split this struct pin, and then plug in the Y and Z coordinates so that we're using the X off of our ball and the Y and Z off of our original location. Compile, save, let's see what this does. There we go, that is an actual paddle behavior. That's something we can get behind. Where it gets tricky is if I go to this score zone and I reconnect their scoring paddle to be our new enemy paddle, then look what happens. There is no way in the world I'm ever going to beat this paddle because it's able to follow along with the ball with computer-like accuracy and predictability. That's something that I'm just not going to be able to compete with. So let's change this so that instead of just copying the location, we are adding movement vectors instead. After all, I do think it's important that the player can actually beat the computer. So for this, we need to make a comparison. We need to see if the ball is above or below where we currently are as the paddle, and then move ourselves depending on where we're going to go. We can use our movement component here by going and triggering something called the add movement input. And if we split the struct pin for the direction, now we have just as much control as before, but we don't have to fill in the Y and Z because this is about movement input, not about the location. But how are we going to simplify two different locations to either a 1 or a -1 value? There's a node in Blueprints that lets us select a float based off of an input, in this case, a Boolean. So our Boolean, when it is true, is going to allow us to pick A. A, I'm going to set as 1, and B, I'm going to select as -1. In the event that this Boolean is true, we will have 1, and then we will move +1 in the X direction. If our Boolean is false, then we will move -1. So how do we set this up? We have to check and see, is our ball above or below our current location? To do that, we are going to do a subtraction. So our ball's location minus our current paddle location. From here, we have to see if this greater than or equal to 0. If our ball is above our paddle, then this is going to be greater than 0. In that case, we want to move up or positively towards that ball to make it closer to 0. In the event that our ball is lower than our paddle, then we want to do the opposite and move down. So let's compile and save and make sure this works. And you can see now that our paddle is now following the ball around, but more importantly, it is not locked to that location in the x-axis. More importantly, we can control how fast this computer can respond by going into our movement component and adjusting their max speed. If I want my computer to be slow, I can set this to be 500. And then when I hit play, you can see that our paddle is moving oh so much slower than it was before. And that is as complicated of an enemy AI as we need to satisfy Pong. So now our game, for all intents and purposes, does work, but there's not very much information on the screen and we still can't technically win. So the next thing that we're going to do together is we are going to first create the ability to display the score on the screen. Then second, we'll create a nice little game over screen for us to use so that I can teach you a little bit about how buttons work. To create a user interface element, we are going to right click in our content browser, go to the user interface section and select a widget blueprint. From there, you can select user widget, and I'm going to call this widget_game UI. If we open this up, you are going to get a brand new screen that is going to mean absolutely nothing to you. This is the UI editor. It can be a bit of a pain to learn. I'm going to teach you the absolute basics. On the left-hand side is everything that you can add to your scene. This giant grid in the middle can be thought of as your scene. And then of course we have our details panel on the right-hand side. The most important thing you can do with UI widgets is add a canvas. So on the left-hand side in the palette, let's look for canvas, and let's drag the canvas panel onto our UI. Inside of this hierarchy, you will see that this canvas panel adds a nice green square to your viewport here. This represents the screen that the player will be playing on. Without the canvas panel, things can get really weird really fast. Now from there, this UI, all we really need to display is two pieces of text, one to display the player score and one to display the enemy score. We're going to do that by using text blocks. So if you go into the palette and type text, you will see we have a rich text block and a regular text block. You're going to drag two different text blocks into the canvas panel. You will know that they are in the canvas panel if you can see a slight indentation between where the canvas panel text starts and where the text block text starts. This means that these text blocks are children of the canvas panel. Click on the first text block. Inside of the scene, you'll be able to see that it's highlighted in this green block. Let's go over to the details panel. At the top here, you're able to set the variable name, and I'm going to call this T for text _ player score. Now, there is a lot that we can adjust here, but we're going to keep it simple. One of the best things to fool around with is the anchors. If you hit the drop down, it will bring up different anchors that you can use. For instance, you can anchor this to any specific section of the board. For our purposes today, let's anchor this to the entire top bar. If I click on this, you will see that this little star goes and pivots so that it takes up and expands over the entire top bar. Based off of where you set your anchor, the offset and positions are going to change. If I look at this offset right, I can hit this little arrow here to reset it to its default value. And now you can see that our text block's size or offset has changed to be dramatically bigger. We don't need it to be that big. So I'm going to change the offset right to be 0 instead. Now it at least takes up the entire top bar, but that's still not what I'm looking for. Let's take a different approach. Under this content section here, I can change the text to be anything that I want. Since we know that this is going to represent a number, I'm going to make this 0 just so I can get an idea about what this would look like in my actual scene. From there, I'm going to press this handy dandy auto size to content button. When I click this, you will see that it snaps and sizes itself appropriately vertically, but not horizontally. That's based off of the anchor that we chose. If I click my anchor and then choose to anchor it just in the middle top, you'll see that the size to content now completely scales in the X and Y direction, and we now have this little tiny box over here. But what's interesting for us, if we're anchored to the top middle, I can reset the position on the x-axis, and now we fly to the middle. But if I zoom in here, you'll notice that we're slightly to the right. That is due to this alignment here. Alignment's what lines you up to your actual anchor point. If I change this anchor to be 0.5, then you will see it pushes us to be right in the middle. And if I make this 1, then it pushes us to the left-hand side. This can be handy if you're ever trying to anchor things directly to that anchor point. For ourselves, I'm going to leave this at a 0.5 anchor on the x-axis, and then I'm going to change the x position to be more to the left-hand side. -200 feels appropriate. And from there, since this is a text object, we're able to go down and change all of our text details. I only really care about the font here because I'm not here to make anything too pretty. Let's change our font to be 60. Since we have this size to content checked, it's automatically going to resize the actual box as we go, which is pretty handy. Now, as a little challenge, why don't you do the same thing with the other text block for our enemy player? All right, let's do this together here. I'm going to show you a shortcut. I really like what I did here, so I'm going to delete the other text block that I haven't touched yet. I'm going to click on this text block that I do like, and I'm going to hit Control-D to duplicate it. And then I'm going to change my X position to be +200, and I'm going to name this to T_enemy score. So assuming you have something that looks about like this, we are ready to move on. The next step is going to be retrieving the score variable from our paddle code and then displaying it using these text blocks. The way we do that is by binding a value to the actual text content that we have inside of our details. Let's start with our player. So that's this left 0 here. With our left 0 selected, go to the content where the text is displayed and click on this little bind button and then hit create binding. This brings you to a blueprint. We are now free to go and get whatever information we want, and whatever we stick into this return node is going to be what's displayed. So how do we get our player's score? Well, first we're going to get our player. Blueprints have this really handy function called getPlayerPawn. If we do that, we are going to get the player. And since this is a single player game, this is a great shortcut for us. From there, we're going to convert this and make sure it's actually a paddle. So how do we do that? Well, we need to cast. So we're going to cast to paddle, notably our player paddle. If this succeeds, which it should, then we're going to get our score. So let's look for score. And you can see that nothing is coming up here. Well, that's because the score is a UProperty, not a UFUNCTION. Let's go into our code. Something that we can do in code is to get a getter function here. So if we call a UFUNCTION that is going to be blueprint callable, we need this to return our score. So it's going to return an integer. So we declare int, and then we're going to call this getScore. Then for getter functions, we can actually do all of the dirty work inside of the header file, and we can say return score. And now if I can Control-Shift-S and Control-Shift-B to build, we have no issues, and we now have a method called getScore that is blueprint callable that is going to allow us to see and use our score variable. So if we go back into our editor, and now I drag off of this, when I look for getScore, it appears. And fantastically, I can now drag this and connect everything up. And we are now going to display our player's score into that leftmost 0. Now in the top right-hand corner, we need to escape the purgatory that is this graph. We can do that by clicking on Designer. Now we're back to our actual canvas here. We're going to repeat the same process for our enemy now. So clicking on the right 0, under text, we're going to hit bind and create a binding. You'll notice that the other binding that we have is here in case we needed multiple elements to display the same information. But let's create a new binding. We're going to do something very similar now. Another handy function that exists in Blueprints is called getActorByClass. This finds the first actor in the world of the specific class. Let's use that. We only have one enemy actor inside of this entire scene anyway. This should serve our purposes very nicely. What class do we want to find? Well, we want to find find the enemy paddle. Then from there, since we're finding an enemy paddle specifically, we don't actually need to cast anything. Therefore, we can call our get score that we just created and then attach this here so that we can display our enemy's score in the other 0. Let's compile and save. Then from there, when I hit play, you'll see that our widget still isn't showing up. We actually need to tell the game that it should use this widget. How do we do that? I'm a sucker for using blueprints for all of my UI stuff. I just find it's pretty clean and a lot easier to keep track of. We are going to do this inside of our blueprint for our player paddle. If we scroll up to begin play, after we do all of the stuff with the mapping context, we're going to use 2 additional nodes. First, we are going to do something called create widget. This allows us to actually create the thing we want to add. What are we going to make? We're going to make a copy of our game UI. Now, our game UI is going to be present throughout the entire game, so this is fine. But what we need to do after is we need to add it to the viewport. This is what adds it to the actual game, or what adds it to the viewport so that we can see it. This on its own creates an object that we can play with. This is what adds it to the scene. If I hit compile and save, and I hit play, we now see our score. And more importantly, as I continue to dominate this enemy paddle, we will eventually see our score is going to increase. But now I'm ready to move on to the final section here, which is to set up a win condition and then display some sort of game over screen. We're not going to do anything fancy. It's just going to be one generic game over screen that has a button that lets us try and play again, and maybe even a quit button because that's rather easy to set up. So first, let's set up our win condition. Let's go into our code and go to our paddle header file. We want to create an event that we can call inside of code that will trigger an actual event inside a blueprint. In other words, we want to create something like this that we can customize and then trigger on our own. How do we do that? So looking at our code, we're going to create a U function. This U function is going to use the blueprint implementable event tag. This is the keyword that we need to get the behavior that we're looking for. Why are we using this and not just doing everything in code? Because I'm a sucker for using UI inside a blueprint. Regardless, this is going to be a void method that I'm going to call game over. It's important to note that whenever you use the blueprint implementable event, do not add this inside of the C++ file. When you use this, you are saying that I am doing everything that I want to do within Blueprint. So if you do anything inside of the C++ file, the game will not work and it will cry and yell at you and you might get a little confused. But what's the best part about this is we can trigger this event from other places in code. Do you remember where we were actually incrementing our score? That seems like the best place to check for the win condition. That was in our score zone. So what we can do is after we increment our score variable here, we can do a quick check. If our scoring paddle has a score greater than or equal to 2, then what do we want to do? Well, we want to go to our scoring paddle and we want to call that method called GameOver. So if I hit Control-Shift-S and then Control-Shift-B to build, we get no issues there. And if I go back to my blueprint inside of my player paddle, now if I look for something called GameOver, we can see we have this new event called Event GameOver. This is going to be triggered whenever any of our paddles has a score equal or greater than 2. So now we just need to make our GameOver widget. Inside of our content drawer, let's right-click, go into User Interface, and then grab a widget blueprint. This is going to be a type user widget, and I'm going to call this W_GameOver. Let's open this up. Just like before, the most important thing we can add here is the canvas panel, and we're going to need a couple things. First, we need a text component. This text is going to be the text that we display that says that the game is over. Next, we're going to use something new called a button. A button is something that you can click on. It's great. We can even do events that happen once the button is pressed. So let's drag a button into our canvas panel. And then further to that, we also want there to be text in our button. So let's take another text component and then drag it into our button. So now we have our canvas panel with text and a button that has its own text. So let's start setting this scene up nice and quick here. Looking at our standalone text block, I'm going to call this T_GameOver. I'm going to change the content to be game over. I'm going to change this to be size to content. I'm going to go into my appearance and I'm going to change the font to be a nice crisp 100. Now we can get even more dramatic, 200. Sure, that looks good. And then we can go down here and justify it to the middle. From there, if we change our anchor point to be the entire top and then reset our offset, you can see we now, if we even go further and set this to be a 0 offset, have this displaying nice and big in the middle there. From there, let's grab our button. If I hit size to content right now, you'll see that it snaps to fit whatever is inside that text block. This could be desirable depending on how big you want the button to be. I'll leave it like that for now because it's going to be nice and simple. I'm going to anchor this to the middle of the screen and I'm going to reset my X and Y position so that it snaps over there. And again, how do we change it so that it's not just awkwardly sitting to the right of our anchor point? Well, we're going to change this to be 0.5. And if we want it right in the center, we could do 0.5 in the Y as well. Now, if I tab into the button's text block, let's make this say again, and then this will eventually reset our game. Then from there, if I duplicate my button and then make its position 200, that's a little much, 75, and I change its text component to say quit, we now have two buttons. Starting with our first button, the one that's for again, I'm going to call this B_again, and you'll see why that's important very shortly. Because now if we scroll all the way to the bottom, we can use this onClicked event here. If I hit the plus, we can now do something when that button is clicked. So what do we want to happen when we click on this button? Well, we want to open a level. If we type in open level, we can do open level by object reference. This allows us to simply choose the level that we want to load, and then it'll do it. So let's find our Pong level. And now when we hit again, we will reload that level and play Pong again. In the top right-hand corner, if you click the designer and then go to our second button, we're going to call this B_quit. And then we'll scroll all the way down the details pane to this on-clicked thing here. We'll hit the little plus. And then if we hit the quit button, we are going to quit the game. We can compile and save that. And now we just need to add this when the game is over. So what does that mean? Inside of our player paddle blueprint, we're going to set up everything that happens for our game over. The first thing that we want to do is we want to make sure that our player can no longer move around. To do that, we're going to disable input. We can do that by searching for a node called disable input. After input is disabled, then we're going to destroy our ball. That way we don't have to worry about the score getting racked up in the background. To find the ball, we're going to do get actors by class. Since there's only one ball in the scene, it makes sense that we can just find it and then kill it. So let's find our BP_ball, and then once we have it, we're going to destroy it. Next, we're going to create our widget. So let's create a widget. This time, the widget that we want to make is our GameOver widget, and then we need to add this to Viewport. So let's compile and save, and then let me show you what this does in practice. I'm going to let the enemy win here, and you can see our GameOver widget's displayed, but I can't move. I can't interact with anything. My mouse isn't appearing. That is because we are still giving input as if we were in a game. We have to change that manually if we want our player to be able to click on these UI elements. So back into our blueprint. After we add this to the viewport, we are going to set our input mode to be UI only. This allows us to interact with those buttons. But further than that, we also need to show the mouse cursor. Luckily, that's something that's pretty easily done. Right-click anywhere and then get a reference to the player controller. From there, using the player controller, we can call a function called showMouseCursor. If we set the showMouseCursor, we're going to set this to true so that we show the mouse cursor. Connect that like so. So now when I hit compile and save, let's run it back and let our computer win. Ugh, how embarrassing. But now I at least have a mouse and I can click on these buttons. What happens if I hit again? The game restarts. How fantastic. But when I hit again, you'll see my mouse is still stranded in the middle of the screen. I can't react. I can't do anything. Or at the very least, I can move, but it's awkward having my mouse here. And if that wasn't worse, we expect a valid player controller as the player controller target. So to solve this error that we're getting, all we need to really do is use this player controller and then drag it so that we are using that so that we set the input mode for our player controller. This is for the situation where the computer wins. We still need to make it so that it's the player's perspective that is the one that is actually doing the controlling. With that out of the way, we now need to make it so that the mouse disappears and we're using game input only when we're starting our game. So let's scroll all the way up to our BeginPlay method here, wherever it is. And then after we add our game UI to the game, let's get a copy of that player controller again. And then off of that, let's look for set input mode to be game only. And then after that, we need to go off of our player controller and then set mouse cursor so that we are no longer showing our mouse cursor. This has the added benefit of us no longer needing to click into the viewport to take control of things when we play. Fantastic. We now have control of our mouse. When I hit again, it disappears and we are able to play another fresh game of Pong. But even more interestingly, when I hit quit, it quits. How successful. You have now successfully completed Pong. Feel free to add to this and keep changing it. There is quite a bit that you can do and change to make the game harder or easier and maybe even take it a little bit further. Subscribe for more Unreal Engine tutorials and good luck in your future projects. Have a great day.